In this video, we're going to continue using Pythagorean Theorem, so that's probably exciting for many of you. You guys seem to like that topic. We're going to apply that to finding distance on the coordinate plane. To find the distance between 2 points on the coordinate plane, there's 3 simple steps. We're going to first connect the 2 points. What you'll notice once we get busy with this is that's going to create the hypotenuse. And we're going to make a right triangle that will create the legs. After we have a hypotenuse and legs, if we're missing a distance, we're going to use Pythagorean Theorem to find that missing side length in a right triangle. Pythagorean Theorem. Pythagorean Theorem is a squared plus b squared equals c squared. Just to get started with kind of really what distance is just measuring from one point to the other point. How many units is that taking up? Most of you are looking at this and saying undefined. And I'm really proud of you for remembering slope. That is slope. The slope of this is undefined, but it has a distance. The distance, I just count from this point to this point. How many units do I get? 1, 2, 3, 4, 5, 6. That is 6 units long. That's the distance. The slope was undefined. Now let's look at the one right below that. I want to find the distance between 6, 1 and 4, 4. So first I should probably plot those on my graph here. These bold lines represent 5, so I know that 6 is going to go 1 after that. 6, 1. And then 4 is 1 before that. 4 is 1 before that. So I'm finding the distance between those 2 points. I've connected my 2 dots, my 2 coordinates. Now I'm going to create a right triangle with them. There's a right triangle. And now I'm ready to use Pythagorean Theorem. How? I don't have any numbers. So we're going to find the length of the legs. This leg has a length of 2 units. This leg has a length of 1, 2, 3 units. And I know a lot of you right now are thinking negative 3 halves. And again, I'm really proud of you for remembering slope. But we're not finding slope today. We're finding the distance. I want to know how long is this line. We can't count because this isn't really a whole one. This is just part of it. So to find the distance here, I've got a right triangle. We're going to use a squared plus b squared equals c squared. We're using Pythagorean Theorem because I've got a right triangle with a missing side length. The legs are 2 and 3, so I can say a squared is 2 squared, b squared is 3 squared, c squared, I don't know that one, so I'm going to leave that as a variable. 2 squared is 4, plus 3 squared is 9, so I should write 9 instead of 3. 3 squared is 9, and then I don't know what c squared is. It was really tempting for me to write 13 here, but I didn't do that. I already had something on the right, so I just dropped down whatever I had on the right. Now I can do that addition. 4 plus 9 is 13 equals c squared. To undo the square, we take the square root of the other side. The square root of 13 is about 3.6. You, again, can just type that in on your calculator. If you're using a TI-83, it's the yellow button second. If you're using a TI-84, it's a blue button. X squared, we want to know the square root of 13. 3.60. I'm going to round to the nearest tenths, so that 6 will stay as a 6. This means that the distance here is about 3.6 units. 3.6 units. From here to here, that's about 1, 2, 3, and most of the other line. This is about the same distance as this. Now looking at we'll look at the top right example now. So first I'll plot the 2 points, -5, -4, 1, 2, 3, 4, -1, -4, -1, 1, 2, 3, 4. Okay, connect those two coordinates. And the next step would be to make a right triangle, but I can't make a right triangle between those. It's a straight horizontal line. And you're looking at this and you're saying 0. And I'm proud of you for remembering the slope. That's the slope. To find the distance of this, I want to know how many units it's taking up. How many lines does this take up? This is 1, 2, 3, 4 lines. So that is 4 units long. Looking at the example right below that, I want to plot -5, -2, -5, -2, and 3, -9. So 1, 2, 3, here's 5, 6, 7, 8, 9. That is just one below that line. Okay. Our steps say to connect those two dots, those two coordinates. That's created the hypotenuse of the right triangle that I can draw. Here's a right triangle. Now I've got this right triangle, so if I knew at least 2 of the side lengths, I could use Pythagorean theorem to find the missing thing. I know how long this is. I know how long this leg is. This leg is 1, 2, 3, 4, 5, 6, 7 units long. And I know that the other leg is from here to here. It's 1, 2, 3, 4, 5, 6, 7, 8 units long. 8 units long. If I know these two, the legs, I can find the hypotenuse using Pythagorean theorem. A squared plus b squared equals c squared. A is 7, so I'll have 7 squared. B is 8, I'll have 8 squared equals c squared. Another way we could have written that is 8 squared plus 7 squared. It doesn't matter which one you call A and which one you call B. 7 squared is 49. 8 squared is 64 equals c squared. And 49 plus 64 is 113. And now I've got 113 equals c squared. To undo the square, we take the square root of the other side. So I need to know what is the square root of 113. Rounding to the nearest tenths, we'll see it's 10.6 units. This is unlike slope because we're not just finding rise over run. I don't want to know how steep this line is. I want to know how long this line is. I want to know the distance of it. To find distance on a coordinate plane, we're using Pythagorean theorem. To find slope, that's where you can use your rise over run. Looking at our last two examples here, I've got -4, 6, so -4 and then up 6, and 8, 1. So there's 5, 6, 7, 8, 1. I want to find the distance there. First I should connect the two coordinates, two ordered pairs. This line helps me with nothing. I'm going to connect 2 legs here to make a right triangle. I'm going to make a right triangle out of that. This helps me. I could either find the slope by calculating rise over run. I'm not looking for the slope today, though. I'm looking for the distance. So I'm still going to need to know what the rise and the run is in this triangle. The vertical length, 1, 2, 3, 4, is 5. The horizontal length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know this makes a right angle. 5 and 12 then are the legs for A and B. And you could have flipped that. You could have said that B was 5 and A was 12. I don't know what this distance is. Since I have a right-angled triangle, a right triangle with a missing side length, I can use Pythagorean theorem to solve for that missing side length. We know A is 5, so A squared is 5 squared. We know B is 12, so B squared is 12 squared, equals C squared is the thing that I'm missing, so that'll stay a variable. C is the thing I'm missing, so C squared stays C squared. 5 squared is 25, plus 12 squared is 144, equals C squared. 25 and 144 is 169, equals C squared. You shouldn't need your calculator on this one because you're an excellent 8th grader who's totally memorized the squares and square roots that we talked about. The square root of 169 is 13. So the length of this line is 13. Now how come I couldn't just count that? You can't count a distance from here to here. That's not exactly 1. I should zoom in so you guys can really see what I'm talking about. Zoom. How far can I zoom in and still get a good picture? I can't say that this is 1. It's not the same length as this, right here, from here to here. I'm going to zoom out because that's a really close-up picture. And we'll look at the last example. I want to find the distance between 2, -7 and -1, 7. So here's 2, -7. And here is -1, 7. I'm going to erase those stray marks that I made. This is a really steep line. I wonder if that'll be shorter or longer than the other things we've looked at. Those 2 points are really far apart. The slope would be humongous comparatively to the other problems because of how steep this line is. But distance doesn't really care about how steep it is. Here's a better picture. You guys look at these and you hate drawing the right triangles between these, something that looks like this, because it is so steep. It's kind of hard to see. So from this dot, I'm just going to draw a line straight down. Straight down. You can go as long as you need to. Now, I'm at this dot. In order to get to that line and close the triangle, I need to draw my line going left. And then you can just erase all of the extra stuff. The length of the vertical line is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The length of the horizontal line is 1, 2, 3. I don't know the length of the diagonal line. I do know that this is a right angle, and the diagonal line is across from that, which means that this is the hypotenuse in this right triangle. That means 14 could be A and 3 could be B. The hypotenuse is the thing we're missing, is C. We've got A squared plus B squared equals C squared. A is 14, so A squared is 14 squared. B is 3, so B squared is 3 squared. I don't know what C is, so that'll stay. C squared will stay C squared. 14 squared, 196. 3 squared, 9, equals C squared. 196 plus 9 is 205. We're not quite done. I want to get rid of the square, so we'll take the square root of the other side. This is where your calculator will come in handy. This is really close up. Make sure your calculator's on. Second x squared, and we're typing in 205. And we get 14.3. 14.3, and if I'm rounding to the nearest tenths place, that's going to say 14.3. So 14.3 is the distance here. That's 14.3 units. This was page 113 in our binders. Your homework is on the next page, and on the first half, you have the coordinates already plotted on the graphs. On the second half, you have to plot your own coordinates. As always, if you have questions about the content in this video, please reach out to me via Schoology. That's probably the fastest way, through my email, or you can drop a comment on this video. I'd be happy to get back to you when I can.